Welcome to another episode of Powering Up Your Formulations podcast, sponsored by BASF Performance and Formulations Additives. My name is Louis Angeles, your host and Global Additives Industry Marketing Manager in North America. I'm excited because today's topic will be focused on a revolutionary market, different than those markets for which our portfolio is dedicated in the paints and coatings industry. This episode will be a fantastic opportunity for the audience to learn how are we expanding our solutions to the batteries of electric vehicles within BASF. So let me provide you a background about today's topic. In the coming years, there is a great demand for batteries for many purposes, including electric vehicles, stationary storage, and electronics. This leads to the need for major growth in manufacturing in the battery sector. So sales of EVs continue to rise globally, but some markets are experiencing a significant slowdown, and many automakers have pushed back their EV targets, and this will influence the battery industry. In fact, the electric vehicles are no longer only a wealthy country phenomenon. Developing economies are experiencing record sales as more low-cost electric models are targeted at local buyers. So the underlying technology for electrification continues to improve, and several next-generation batteries technologies are reaching commercialization in the next few years. In fact, the annual lithium battery demand grows rapidly, approaching almost 6 terawatt hours annually by the 2035. Meeting this demand requires large but achievable increases in materials, components, and cell production. According to the Bloomberg New Energy Finance market study, at least $35 billion needs to be invested in the battery cell and component plants by the end of the decade, which is easily exceeded by the $155 billion already planned by the companies. So, in conclusion, there is the potential for the rapid growth in the battery manufacturing in North America in the coming years. It is feasible and it is real. So, as I mentioned, there is an indicated investment plans by which the companies, different companies have announced, and we are looking for taking advantage of this battery growth rate. So today, my guest and I, we will be talking about what ED, the Dispersions, Resins, and Additives division within BASF, is suffering in the battery cell manufacturing market, and how our products can support the growth of manufacturers in North America. Hi, Natalie. Welcome to the show. So it is a pleasure having you. And well, I know that you have a huge experience at BASF in different segments, but today you and me are new in this battery market, and we are learning each other with our customers and with the industry. So it is a pleasure, as I said, having you here with me. And well, I would like you to introduce yourself with the audience and tell us a little bit about your team and your responsibilities within the company.
Absolutely. Thank you for having me today, Louis. So my name is Natalie Nicewicz. I am the market segment manager for Nonwovens in North America. And part of that is managing the Licity battery binder portfolio here in North America. So I am part of a wonderful team that spans not only North America, but Europe and Asia that are launching this new brand of battery binders to global customers for EVs and consumer electronics alike. So it's a really exciting space. And as you mentioned, we're both relatively new, but this space is growing so rapidly that it feels like it's changed already so much in the time that we've been in it.
Yeah. Thank you, Natalie. Thank you for letting us know about your experience and also your responsibilities and what you are doing with the Licity team. So, well, I mean, within BASF, for sure, we have we have been a strategic partner for e-mobility. So there are key figures that you can see about the quantities that we have invested in research and R&D, but also how we are transforming the powertrain and in the vehicles with different product portfolios like battery materials, chemicals, plastics, surface technology, coolants, and components for lubricants. So, I mean, but at the end, it is interesting how our division is also finding out the opportunities in the market. And I invite you because, well, I would like to learn more about your Licity product. And really, between you and I, explain to the audience what our portfolios can be used in the battery packs inside of the batteries, and how we can transform the battery industry and support our customers with great performance through our products. So having said that, I have some questions for you. And well, if you don't mind, I would like to start with the first question. So you mentioned Licity, and you said that it is a binder. So if the binder, if such a small portion of the anode, why it is so important for the batteries?
Yeah, so the binder is actually only about 2% of the total anode composition, but it has a really large impact on the battery performance and the longevity. And so when you think about that, you think about both the physical properties and the electrochemical properties of any given battery. So first, physical properties are important to consider since batteries can swell as they charge and discharge. And so here at BASF, we look closely at bending, peeling, and adhesion properties to make sure that the battery structure stays intact over the life of the battery. In particular, we also look at peel, and this is extremely important for cell manufacturers as they are scaling up on a gigawatt hour scale, making sure that the processability is easy to work with. And then you look over at electrochemical properties, and they're important because they impact the lifetime of the battery and also the overall safety of the battery. So we evaluate cycle performance at 500 and 1,000 cycles, and we look at DCIR, or internal resistance, which impacts the ability to charge quickly. So that's a pretty common trend in the battery segment. And then also capacity retention, which impacts the longevity of the battery. So all of those factors come together to make a well-performing battery, and the binder is a small but very important part of that.
Okay, wow. Interesting. And Natalie, so you mentioned this. I'm wondering, why are SBRs an ideal chemistry for anodes? I think you have this information. So
yes, so the binders, they come in a couple of different forms, but SBRs, or styrene butadiene rubbers, are really common in this space. And they're important because they provide flexibility to the anode, but also give excellent adhesion to the anode materials to the current collector, like copper. And additionally, SBRs are known for their heat resistance, which is especially important in a battery system because it can prevent premature aging and also some safety issues. So as I mentioned earlier, there are charging and discharging cycles. The battery can get very hot, so it's important to keep the battery system together using an SBR. When you come in a couple of different forms, but SBRs, or styrene butadiene rubbers, are really common in this space. And they're important because they provide flexibility to the anode, but also give excellent adhesion to the anode materials to the current collector, like copper. And additionally, SBRs are known for their heat resistance, which is especially important in a battery system because it can prevent premature aging and also some safety issues. So as I mentioned earlier, there are charging and discharging cycles. The battery can get very hot, so it's important to keep the battery system together using an SBR. When you look at the electrochemical performance, SBRs work well with both graphite and silicon and some other anode materials, which give formulators a lot of latitude when developing next generation solutions. And Including that latitude, BASF also has a polyacrylic acid solutions, which can be used to reduce swelling and increase some of the electrical chemical properties of the anodes with higher silicon loading. So you can use SBRs with PAAs and still have that flexibility and adhesion, but you can provide a little bit more stiffness to reduce the swelling and increase the battery performance.
Okay, so if the customers would like to know more about Licity and all these products, they should reach out to you and your technical experts, and I'm pretty sure that you will provide more information.
Absolutely.
Okay, well, when you explain about these Licity products, so I'm thinking why it is also important for suppliers to have a global presence for the battery production.
Yeah, so we know that there are a lot of global suppliers in this market, and even those with local production are impacted by supply chain issues. So I guess the first piece I'll touch on is the Inflation Reduction Act, which really impacts not only large components of the battery, like cathode active materials and anode active materials, but also smaller materials like binders. So as those percentages continue to increase over the years, the battery can be a couple of percentage points to help you be eligible for the Inflation Reduction Act and allow your customers to get that tax credit. On the other hand, even if you're not shooting for the Inflation Reduction Act, having a security of supply is really important because binders are not typically interchangeable in anode formulation, so manufacturers really need to make sure that they have supply on hand to keep up with their end markets like automotive and electronics. So each one of our markets have multiple redundancies in our local production, so we can supply that and make sure that no matter what, our customers are supplied in a timely manner for their customers and ultimately consumers like us.
Okay. Thank you, Natalie. Thank you so much for showing us all this information. I think, well, the audience will be interested in learning more from you and your experts. So, yeah, I mean, this is really, really helpful to understand more about what dispersion resins and additives are doing in the battery market. So now I think, well, as you mentioned, Licity is a binder. It's used in the anode side of the batteries. So we also are offering some additive solutions. And well, I can share with the audience more about the additives products. But well, before to explain more, I don't know if you also have any question or comment.
Yeah, absolutely. As you mentioned, batteries are new for both of us, and so I'm still learning about the additives portfolio. So the first question I have is why are additives used in the battery cell manufacturing process?
Yeah, thank you, Natalie. Great question. Overall, additives are used in the battery cell manufacturing process, as you can see here in this slide, in different stages of the electrode processing. But well, really the key attribute of our additives it is how they can enable the optimization of the electrode formulation, the electrolyte composition, the cycle life, and the safety and the performance of the battery. So we need to do a careful selection and incorporation of the additives to really enhance the overall efficiency and reliability and longevity of the batteries. Just as an example, in the electrode formulation, I will say that additives play a crucial role in the formulation of electrode materials for batteries. They are used to improve the performance and stability of the electrodes by enhancing the conductivity, optimizing the particle size distribution, controlling the porosity, and facilitating the interaction between active materials and the electrolyte. Our business has been focused to offer solutions to the slurry preparation of the cathode, anode, and separator components, in addition to the coating layer and calendaring process. So some of the benefits of using the additives portfolio are listed here in the right side of this slide. But yeah, I mean, it depends on how the battery technology is developed to really get the best performance of our products.
Wow. Yeah, that's really interesting. There's so many different types of chemistries that go into a battery just on the additives portfolio. So in particular, how do the dispersing and wetting agents interact with active materials, binders, and the electrolytes in the battery cell?
Yeah, well, dispersing and wetting agents are designed to improve the distribution and wetting of the active materials within the electrode slurry. And they can help to reduce the agglomeration of particles, ensuring a more uniform distribution of the active material particles within the electrode slurry. And this uniformity is critical for consistent electrochemical performance across the electrode. Having homogeneous slurries lead to even current distribution, but also reducing the risk of localized hotspots and enhancing overall battery efficiency. I would like to say that the chosen dispersing and wetting agents must be compatible with the binders. So this is a good cross collaboration that we can do with the Licity. Just for example, the other binders like the PVDF using the electrodes to maintain the mechanical integrity of the electrode structure. It is something that we can do, but also with the binders like Licity. In fact, the properly selection of the dispersing and wetting agents can significantly improve the electrochemical performance of the batteries. And also improving the mixing efficiency of the electrode slurry, reduce the time and energy required to achieve the homogeneous mixture. So at the end, this can lead the faster production times and lower manufacturing costs. So at the end, improving the wetting properties facilitate a better coating of the slurry onto current collectors. And yeah, as I explained, the uniformity in the layer, it is critical and consistent for the battery performance. So in summary, the careful selection will help you to optimize the dispersing and wetting agents formulations and with the binder, and also achieve a good performance, efficiency, and cost effectiveness for the battery cell manufacturing.
Yeah, and all of those sound really important, especially not only as we scale up new factories, but try to keep up with the demand for batteries. It'll be crucial that we're as efficient as possible and also making sure that we're producing quality product. And so you have on this slide about thicker cathode film. So yeah, when we're thinking about calendaring, why is it better to have thicker cathode films?
Yeah, having a thicker cathode films can lead to improve the energy density and electron chemical performance, but also the mechanical stability. So in addition to the current distribution and safety of the batteries. So, however, it is important to strike a balance as excessively thick films may result in increasing diffusion lengths and a slower ion transport, which can negatively impact the battery's performance. So as I mentioned before, so you really need to choose carefully how you will be incorporating the additives, and in this case, to have the thicker cathode films.
Ah, okay, that makes sense. And then my last question comes from kind of a hot topic in this battery space about solid state batteries. So can BASF's additive technologies be used in solid state batteries?
Yes, we can use and recommend additives in the solid state batteries, but we are still learning on these technologies, and we are exploring with the customers through our existing offering. But for now, we are more focused on understanding the lithium-ion batteries and also how the battery technologies will evolve. But in summary, I mean, the short answer to your question it is yes, but I would like to take advantage of your question just to remind to the audience that the additive solutions that we have, it is for the lithium ion. And well, here it is a quick explanation as you did with the Licity binders, which kind of additives you can use for the different electrodes of the batteries. And yeah, I mean, there are differences between all of them. For sure, the performance can be important in any of these recommendations. So happy to share more information.
Absolutely. Yeah, that's great to think that you cover both kind of the current technology and the future of all of the batteries. So that's all of my questions. Thank you for answering them.
No, thanks to you, Natalie, for talking with me about this exciting topic. So we have working together on this battery segment, and I think we will continue showing to the audience more information in another episode. So hopefully we will have a better another insights and also better understanding about what will happen in the next year. So thank you again. And I mean, really, it was a pleasure having you here with me in this episode.
Absolutely. Yes. Thank you again for inviting me to your podcast.
So Natalie, I mean, I don't know if you have anything else that you would like to share with the audience, because I think there are exciting news about where we will be exhibiting our products.
Yes, if you'd like to see us, we'll be at the Battery Show in October at booth 3000. So we'll be displaying all of BASF's e-mobility solutions. And in addition, we'll also have our product specialists on hand to answer any questions you may have after this podcast. So feel free to reach out immediately after. But if you'd like to see us in person, that's where we'll be in October.
Thank you, Natalie. So yeah, hopefully our customers will meet with us at the battery show. So thank you very much again. So I encourage the audience to visit our website and reach out to us through our email contact information. If you want to learn more about the Licity and additives for the battery cell manufacturing, please go to our website, www.bsf.us/DP solutions. And there are more information about our products. So hope you can listen us in the next episode. Thank you very much and have a great day.